Right, we are starting with section 6.10.6 today, and in this section we are going to talk about solving equations that involve radicals. Now we've looked at how to add, subtract, multiply, and divide them. In this one we're going to try and do the same thing but in terms of equations instead of just operations. So when you're talking about an equation with radicals, you're basically saying it's an equation that will include radical expressions that have variables. So you can expect to see something like square root of x minus 9 be an equation with radicals. You can have something like this here, square root of 4x plus 12 equals 2 times square root of 2x minus 1. Again, these are both examples of, before we start solving equations, we want to talk about the power rule. And this rule will help us in solving equations with radicals. Now, what this rule says is basically if both sides of an equation are raised to the same power, then all solutions of the original equation are also solution of the new equation. What do we mean by that? Let's say we have this equation x equals 1. Okay, and this equation has only one solution, and that solution would be, of course, the set with number 1 in it. Okay, now the idea is if I square both sides of this equation, okay, so let's say we square both sides, you will end up with x squared equals 1 square, which of course we know is 1, so x squared equals 1. Now what your power rule is saying, that whatever are the solutions of the original equation are also solutions of the new equation. So let's see if this is true. Now if you solve x squared equals 1, you will see that the solution for this will be negative 1 and 1, and you can verify that negative 1 squared will give you positive 1, and of course 1 squared will also give you positive 1. So your new equation has two solutions. You will notice that the solution negative 1 is not a solution of the original equation. We said in the original equation your solution set was only positive 1. When you squared the original equation, you ended up with negative 1 and positive 1 as the solutions. So this is where you have to be careful. All the solutions of the new equation are not going to be solutions of the original equation, but solutions of the original equation are solutions of the new equation. Okay, so this is the idea that we want to try and use in solving equations with radicals. So just like we did here, we will exclude the solution of negative 1, and this is what we call as the extraneous solution. Okay, and so we will go ahead and discard it. Okay, so we don't want to use negative 1 as part of our solution set for the original one. We use only but positive 1. Now anytime you use the power rule to solve equations, always you want to check your answers. Always make sure that the solutions you came up with, you can use that in the original equation. If you can't, then you would want to discard those solutions. So let's look at this example, and we'll use the power rule here to help us out. So by power rule, we'll go ahead and square both sides of our original equation. Okay, so square the left-hand side, square the right-hand side. Now why do we square it? Because the square will cancel out the square root. Okay, you want to get rid of that square root symbol, and you will end up with 6k minus 1 equals 1. Okay, now go ahead and solve this equation for k. So we will start by moving the 1 over to the other side, and this gives you 6k equals 2. Now divide both sides by 6, and you'll end up with k equals 2 over 6, or you can reduce that, and that will give you 1 over 3. Now you can see in this example we came up with only one answer as our solution, so we'll go back to the original equation and check to make sure that 1/3 will work in our original equation here. So substitute k with 1/3. Okay, and let's see what we end up with. So 6 times 1/3 will of course give you 6 over 3, or that will give you 2. Okay, 2 minus 1 is 1, and of course square root of 1 is 1. So you end up with a true statement, and that tells you that that 1/3 is indeed the solution to your original equation of square root of 6k minus 1 equals 1. So you can say your solution set will be the value 1/3. Okay, so you can see it works out really well once you use the power rule and get rid of that radical sign, and then you can find the solution to your unknown variable. So let's do a quick take a quick look at the steps involved in solving an equation that has radicals. Now the first step is you isolate your radical, which means that make sure that only one radical term is alone on one side of the equation. So if you ended up with 2 radical terms in your equation, move one to one side and the other to the other side. So you want to isolate your radical. Your next step is to apply the power rule, like we just saw in that example. Raise both sides of the equation to a power that is the same as the index of the radical. So if you have a cube root, when you apply the power rule, you raise your equation to the 3rd power. If you had a 4th root, you raise it to the 4th power. So your power has to be same as the index of your radical. Now once you do that, then of course you will go ahead and solve the resulting equation. Now here is where you want to be a little bit careful. If at this point it still contains a radical, you will go back and repeat steps 1 and 2, because you want to get rid of your radicals completely. So that's what step 3 would be. And step 4 is where you check all the potential solutions in the original equation, not the new one, the original. And if some of the equations, the solutions don't work in the equation, you will go ahead and discard those.